today's video, we will be discussing a problem from Leetcode, which is Divisor game. It is a dynamic programming problem, but it has a mathematical proof to it also. Basically, which is very easy solution, but sometimes it's become difficult to get up to that point. So I will be discussing both the solutions. So firstly, I will be discussing the dynamic programming solution. So let's read the problem. Basically, Alice and Bob take turns playing a game, and Alice is starting first. So Alice starts first, takes first turn. There is a number n given to us, and here are the rules for the game. On each player's turn, that player makes a move consisting of, for example, if a turn is of Alice, then she will make turns she will perform following things, and if it is Bob's turn, then he will perform following things. So he or she can choose any x. Basically it is an integer which is ranging from 0 to n. Okay, so they can choose x, and the condition is the x that they are choosing, it should fulfill this condition, which is n modulo x should be equal to 0. So we have to keep this thing in mind that whatever x we are choosing, firstly it should fulfill this condition, then only we can choose it. Okay, so if we have chosen some x, then replace the number n we were given on the chalkpad with n minus x. So basically we have to subtract x from the given n. Obviously n will keep decreasing. So what else the question is saying? If the player cannot make a move, they lose the game. Okay, so if the player no move is available, so obviously that player will lose the game, and we have to return true if and only if Alice wins. So basically true will represent that Alice is winning. So yes, that's the question. So I hope you were able to understand the question, and if there is some difficulty, you can try to read it once. So now let's discuss some test cases so that the question is more clear. So since we were given that Alice will take the first turn, so in case the n is equal to 1, so we have to choose one x. Alice has to choose one x, but we were also given that x ranges from basically 0 to n, but obviously there is she can't choose any x possible. Basically there is no x possible from 0 to 1. So in this case Bob will win, Alice cannot win. So basically it is false. For this test case the answer is false. So if we are given n is equal to 2, what will happen in this case? Okay, so firstly we will check range of x. Basically x is ranging from 0 to 2. So okay, 0 to 2 we have only one option available, which is 1. So okay, it is first turn is of Alice, she chooses 1. Okay, then after that next condition was to check if n modulo x is equal to 0. Is it so? Yes, n modulo x is in this case is equal to 0, basically 1. Here x is 1. So what will the next n be reduced to? So next n will become 1. So in this case Alice has taken her turn. Now is the turn of Bob, and what n is available to Bob? So basically it is 1. Now again Bob will do the same thing. He will check the range, which will be basically from 0 to 1, and he cannot choose any x between 0 and 1. So obviously Bob will fail and Alice will win, and if Alice wins we have to print true. So for this test case the answer will be true. I'll be taking this test case. Here n is equal to 5. We will not completely solve it, but yes, we will understand what kind of complexities are we going into. So basically it is first turn is of Alice, so range of x is from 0 to 5 basically. Now we can choose, Alice can choose 1, 2, 3 and 4, but the condition arises another, that n% x should be equal to 0. Here n% x should be equal to 0. So we will Alice will verify. Okay, so n% 1, is it equal to 0? Yes, in this case it is equal to 0, but not in this, not in this, not in this. So only option available to Alice is to pick 1. Okay, so if she picks 1, then the n for Bob will be reduced to basically 5 minus 1, which is 4. So basically the problem for Bob will be now reduced to 1, 2, 3 and 4. And since for Bob n is equal to 4, he can choose from 1, 2 and 3. Again he will check for this condition, which all are satisfying this condition, like 4% 1, is it equal to 0? Yes, it is equal to 0. 4% 2, is it equal to 0? Yes, it is equal to 0. 4% 3, is it equal to 0? No, it is not. So Bob has two options to either choose from 1, either choose from 2. So in either case, like if he chooses 1, then n will be 3, reduced n will be reduced to 3, and this 3 will be for Alice, and if he chooses 2, then basically it will be 2 for Alice. So she has to check for either of them, which will lead her to win the game. So it is becoming more complex and complex. Basically it is becoming a recursion like tree, so which is not possible to obviously draw here. So we will be trying to code this problem first, brute force approach, basically recursive one, and I'll be explaining that. So I will be making a function which will be of Boolean type, and here I will have an integer n, basically this n only. So and another uh, boolean which person. So which person here, so let me clarify. Here we have taken this boolean as which person. Here which person defines like if it is true. Basically this boolean will this which person will tell us, is it Bob's turn or is it Alice's turn. So if it is Alice's turn we will take it to true, and if it is false then we will understand, okay, in this time it is Bob's turn. So okay, so now we have to jump out to next condition. Next condition was we have to check this condition. Okay, so to do that we will be starting a loop from x is less than n and x plus plus. Now okay, so this loop will check to all the valid x, like for 1 2 3 4 5 6 7. Okay, so it will check all of them. Now we have to put another condition. This condition is n% x equal to 0. So we will be putting it in case if n% x equal to 0. Okay, so okay, we are done with both the conditions, but another situation arises. It is important for us to know, okay, is it Alice's turn or is it Bob's turn? So we will be making it basically if which person which is of Boolean type is equal to true. Basically, it is Alice's turn currently going on, and else if it is false, then we need to understand that it is Bob's turn going on. Okay, so if it is Alice's turn going on, we will first take this case. So basically what will happen? We will call same function. Now since it is Alice's turn, then we will call this function and reduce the value of n by x. And now we have to be very careful here. We have to parse false in this function, as it is a sign that this function, basically the next turn is of Bob, because we have initialized that if it is false then it is Bob's turn. Obviously if it is Alice's turn going on and next turn should be of Bob, so the next function that we will call herein will be for Bob, so yes, it is false. Similarly, if it in the case of if it is Bob's turn, then we will reduce the same thing, but here we will, if it is false then we will make to true. Basically what we are doing is, if it is currently Bob's turn is equal to false, then for next turn we have to make that, we have to keep a track that okay, next turn is of Alice, so here we parse true. Similarly, Alice's turn was true, then for next turn we passed false. So yes, this is the slight modification done here. And now an important part comes here. Basically this function will return us, okay, that true or false. If it returns true, then it means that the last turn which the person that was not able to play was, basically if it comes to be true, then that means that basically after taking Alice's turn, after all the iterations and all, the last turn was not able to be performed by Alice. Basically if B is equal to true, then Alice was not able to perform last turn, basically she lost. And if it is false, then that means that the Bob was not able to perform the last turn. So if basically if B, we need only one, any one possibility that we such that Alice should win. So basically if B is not, basically if B comes out to be false, then Bob has lost, that means Alice has won. So yes, we have to return true from here. True meaning that yes, Alice has won. Similarly here, if after Bob has taken his turn and after all the rest turns that took place and the result came out to be false, that means the last turn he was not able to take it last turn, so he lost. So basically if basically B is false, and then we have to return true. And so this is it. And in case if it does not enter this loop, basically if it is if no x is available, like in this case for 1, so what should we do? We should simply return false, okay, because we know that first turn was of Alice. So yes, Bob will be the one who will not be able to take the last turn. So here we will return basically false. And let's call this function and true. Here we are passing true because to signify that the first turn is of Alice. So let's try this out if it is working. Yes, so it is working. So let's try to submit this. And here we realize that since we are trying to submit it, so time limit exceeded has come. So basically time limit exceeded has came because we are doing it recursively, and we know that for during recursion the time complexity is really high. So what else can we do? Okay, so there are two concepts basically. Like we can pass a DP table, but how can we pass a DP table? Because it is somewhat not related to only one state. Here two states are involved. Two states are involved in the way like basically the answer is dependent on the currently n and the who's the person whose turn it is. So basically it is two states. So we can either do 2D DP, but if I have taken like boolean here, if I had taken like integers like 1 and 2 and kept on changing them, switching them both, so in that case I could have taken like an integer DP array. But here I will take hash map. I'll parse a hash map. The main idea of basically parsing the hash map, it is same as DP array. Basically the concept of DP array is to not calculate same thing again and again. So yes, I will take care by passing a hash map. So basically string type and boolean. So here also here keep in mind that in Java it should be capital B here, and obviously it's generic so not required here. So okay, so we have to pass it here also. Now we have to put a condition if map dot contains key. Now I will be making key like a string. So basically I have involved both the states n and boolean, which person basically. So yes, I have involved both the states. So I will make a string of them like n plus which person. So yes, if it contains this key, then we can simply return map dot get which person. So we can return it from here only if it already has been computed, and we have to put here our answer before it is returned, and that is same thing. And what should it be? True in this case. Similarly, I'll be copying, and yes, that is it. Here also we have to do false. I think it should work now. Yes, it is working. Let's submit it. Okay, so basically it has been successfully submitted, but the time here is just 7.50. It is actually slower just because I'll tell you something. Since we have made like this hash maps key is string, so yes, when the key is string, so it will basically the time complexity of searching will be basically the length of that string. So yes, that's something a tedious task, as in string the basically string is compared by character, so that's why it is taking some more time. And we have used hash map also, so hash map is nearly O of 1, not completely O of 1 but nearly O of 1. So that's another issue, the basically that's arising. If we have taken here like boolean which person, instead of we had taken integer, and I kept like for Alice turn like 1 and for Bob's like 2. So if we had been switching between them, so yes, retrieving from array is actually better approach. So obviously that time complexity will also improve. In the next video, I will be discussing the mathematical approach and the proof of that approach. So yes, till then, stay tuned and like, share, and subscribe. Thank you.